All right, so far we've talked about solving quadratics by graphing, and we also use a table. We've used factoring, and we've used the square root property. And so today we're going to talk about another way to solve quadratics, which is by completing the square. All right. Now the shortcoming or the downside to some of the other properties, graphing, especially if you have your graphing calculator, that can always work to find your solutions to a quadratic, or your roots or your zeros or your x-intercepts. But factoring doesn't always work. Factoring, an equation has to be set up nicely. You have to have those values for b and c, where you can have a product of two numbers that have two numbers that have a product of c and a sum of b. That doesn't always work out to where that's the case. And the square root property only works when b is equal to 0, at least to this point, right? We're actually going to use that with completing the square. And so that doesn't always happen where b equals 0, right? And so anyway, completing the square is the first algebraic method. So taking out graphing, it's the first algebraic method that is foolproof. Okay, and then we're going to learn another way that actually it's derived from completing the square, but it's probably the most straightforward way, which is the quadratic formula. All right. So just to remind us about the square root property and kind of the basis of completing the square. Remember back to the last video, and I think we actually did the same problem on the last two videos. One we did it by factoring, and then we also did it last time by the square root method, right, where we added 100 to both sides, and then we got x squared equals 100, and then we took the square root of both sides, and we had to remember to put a plus or minus in front, right? And so square cancels out a square root. Oops. And so we end up with x equals plus or minus 10, right? So we're going to do a similar thing, but now we're going to do it, instead of just having an x squared here, we're going to have a binomial squared, okay? And so this comes back to remembering that if I have something like this, a plus b quantity squared, then what I'll get is a plus b times a plus b, right? And if I FOIL that, we'll get a squared plus ab plus another ab plus b squared, right? And what happens is when we combine like terms, we have these two middle terms that are exactly the same, and so we just get 2ab, right? If we add two things that are exactly the same, we just double it basically, right? And so that's what we get. So that's what a perfect square quadratic or perfect square trinomial looks like. And so, and by the way, if this is a negative here, then that'll change this to a minus and this to a minus, right? And so that'll change this to a minus, this to a minus, and then that'll make this a negative 2ab. Notice how this sign doesn't change, right? Because if this is a minus and both these are minuses, then if I multiply a negative b times negative b, I still get positive b squared. So this sign is always positive, but this sign is always the same as whatever this sign is, okay? All right. So completing the square, here's our vocab, and just this one term here. And so completing the square is a method used to manipulate a quadratic equation so that one side is a perfect square, which allows you to use the square root property to solve the equation, okay? So we just did the a plus b quantity squared. Let's try it with x and p, just to because we're usually going to have an x there, and then we'll have a constant in the other spot. So if I square x plus p, that means I'm going to multiply it by itself, right? And so if I FOIL this, I'm going to get x times x, x squared, x times p, which is xp or px, right? Usually put the number in front, so p P is the constant, so we'll put that in front. Then we'll have another Px. And then we'll have P times P, which is P squared. Okay? And so when I combine like terms, I'm going to get x squared plus 2px plus p squared. All right? Now let's investigate a little further. For one, if I have a minus here, that's going to make this a minus, this a minus. This will stay a positive, right? Because a negative times a negative is a positive. And so that'll just change this, right, to a negative. So, all right. So remember that whatever this sign is, that'll be the same as this sign. Now let's align this with what we have on this side, right? That's where you're used to seeing. And here I just left a out of it, but a is an invisible 1. But you can actually, I'll show you an example at the end where a is bigger than 1 if we have some time. So I'm going to put this here, 2px plus p squared. Okay, so what I can see here is that this bx term is equivalent to that 2px term, right? So b is equal to 2px, right? Or let me see, let me do this. Let's take out the x, right? Because we just see that. Let me see. We can just see that b and 2p are the same, right? So b is equal to 2p, which means if we solve for p, that's b over 2. So if I want to find this term here, p, I can just take that b value and just divide it by 2, okay? So the linear term, if I take the coefficient of the linear term and divide it by 2, that'll give me that term right there, okay? All right, now let's look at c. So c and p squared are the same, right? So I can say that c equals p squared. And so if I take the square root of both sides, that means that p equals the square root of c. Okay? All right, so if I want to find, so that's another way to find p, is just to take the square root of c. Okay? All right, and we can go both ways, right? Like if I want to go from here to here, then this middle term is just going to be double whatever p is, right? And the c term is going to be the square of p, okay? The square of this p. All right. So anyway, that gives you some kind of background on this. If this was a little confusing because of all the variables, don't worry about that. When we see some examples, you'll see that it's a little more straightforward than this with real numbers, okay?